Okay. Hello everyone. What's your name?
Vedan Divedi.
Vedan Divedi. So today we are going to do the experiment 4-volt tester. Using this equipment 4-volt tester, we are going to find out the square diameter of the steel balls. Okay. So it's written new ball here and it's written old ball here. Okay. Old ball, new ball. So for each experiment, each iteration, you have to take 4 new balls every time, each having 12.7 mm diameter, and this is steel ball. Okay. This is the ball pot assembly. This is the ball pot assembly in which you have to keep 3 balls. Okay. So that it will be stationary. Okay. Now you have to fill the lubricants. Where is the lubricant? So you have to fill the lubricant so that ball will be submerged. Okay. And this lubricant is the 20W40. Okay. 20W40. Lock this. With the help of torque wrench. This is the torque wrench. In that already torque is set already to 68 lb feet. If you see here, 68 lb feet, and if you see here, 98 Newton meter and 68 lb feet. Okay. Now with the help of that, you have to lock it. This is the arrow side. In the direction of arrow, you have to rotate. Till click down, you have to rotate it. So this is the ball pot assembly, and this is the ball recess assembly. Okay, and this is the collet, in which 4th ball you have to attach. So this is the ball recess assembly. Like that, you have to attach the 4th ball, and if you want to remove, you have to press back. Now, good luck. So this is the spindle. Okay. This side motor is there, and this is the power. So with the help of that, we can supply the power, and motor will help to rotate the spindle. And then in a spindle, you have to attach the collet. This is the collet. So 4th ball will be rotating, and other 3 will be at a stationary condition. And 4th ball making point contact with other 3 balls. Okay, making point contact. So now here we have to apply the load. So we apply the 6 kg load as per the ASTM standards. ASTM D596 and D2783 we are going to follow. So in that we have to apply the load, and at each load duration will be 10 seconds, and room temperature is the 27 plus minus 8 degrees Celsius, and speed is the 1770 plus minus 60. So these 3 is the constant during this experiment, and this is our input parameter. So with the help of dead weight, we are going to apply 6 kg load, and this is the lever. So 6 kg load we are going to apply here, but actually at the ball 15 times, like 90 kg load is applied with the help of
Applying the 6 kg.
because of lever load. Okay, because of that lever load ratio, 6 kg if you apply here, 90 kg will be active. So 90 kg load is going to apply. So you have to remove this. So now if you see, 3 ball will be stationary, making contact with the 4th ball, and if you switch on the power supply, now it will rotate. So we have to rotate for 10 seconds only. As output, we will get a scar on all 3 balls. You will see a scar on other 3 balls, and the rear track will be developed on the 4th ball. So with that rear track, we have to measure the diameter with the help of vernier caliper, so that you know the radius of the ball or diameter of the ball, fourth ball, and torque is applied. So you know the torque you will get from this display box. Torque you will get from display. So you are able to calculate the frictional force. Okay. So you know the frictional force, and whatever load you apply here, there is a normal load. So ratio if you take, you will get the coefficient of friction. So with the help of this experiment, you are able to find out the coefficient of friction. Is the one thing. Second thing is the find out the star diameter on the other three balls. That star you have to check through the microscope and take the average. This is the microscope. On this other three ball you have to check it and note down the average dia of the ball in the microscope. That is the star dia. So second thing is to find out the star dia. And first thing is to find out the coefficient of friction. But main purpose of this experiment, but the main purpose of this experiment is to find out the characteristics of lubricant. Like you are using this 20W40. So suppose in
what
that
characteristics it will be?
I am telling you. Suppose with the help of this 20W40, you got star dia is like 30 micrometers. Suppose, but using this lubricant 80W90, you got 20 micrometers. So which lubricant is the better? If I ask you.
What kind of this?
No,
Decide that.
The star diameter. I am asking you.
I don't know.
You don't know. Okay. Let me
जिसमें फ्रिक्शन कम होगा ताकि वो कम बने
Okay.
इसका डाया कम बन गया
explain it. See. In that, you fill the lubricant, and if you see here, in other three ball, a scar is developed. Okay. See here, at H3 ball, like you got 20 micrometer, but with using that lubricant, you are getting 30 micrometer. So I can ask you, like, which lubricant is the better one? In terms of
which have the lesser diameter?
That is the thing. Less wear, that is a good lubricant. So main purpose of this experiment is to find out the quality of lubricant. But because of time constant, we are using only one lubricant. But in your research, like if you are coming in M10 second year, if you want to do a research, you can test different oil and find out the characteristics of lubricant. Or you can develop your own oil, like in our lab one senior somewhere in Guru, he developed oil and he found out that he got very good quality of lubricant compared to these two, and he published in quality human journal. So that is the thing. And now you have to take these three balls and this fourth ball. I will tell you. See, if you see here, wear track is developed.
Yes.
So smooth, wear track is developed. That track diameter you have to measure through the vernier caliper. You know, this is the vernier caliper. With the help of that, you have to measure the diameter. Okay, but in vernier caliper, if you see, here also 0, here also 0. So some people ask me, sir, if a value is come at 0.4, I have to take 0.4, here also 0.4. No. If you rotate from this to this, it came 1 mm. Okay. Now see, it is visible 2 mm. So with complete 1 revolution,
2 mm of
2 mm. That's why least count is 0.02 mm. So like that you have to measure. Suppose this is the main scale reading, this is the vernier reading. In main scale, like 20. Okay, 20. So now you have to take 20 plus it is between 0.1 and 0.2. So first you have to take 0.1. 20 plus 0.1 plus least count into number of division. 5 division is there, right now in the first division. So 1 multiply with the 0.02. So 20 plus 0.1 plus 0.02. 20.12. That is the. So with the help of that, you have to measure the diameter. And you know the torque value with the help of this display value. So you can able to calculate like frictional force, and you know the normal force. Right. So we can calculate coefficient of friction. So you have to plot two graphs: load, normal load versus frictional force, and one thing is the normal load versus scar diameter. So this will give you, and with the help of these three balls, now again I have to unlock it with the help of torque wrench, but in opposite direction. Okay. So before removing this ring, you can mark where the contact is there with your this marker. You can mark so that it is easy to find out the location. Okay. Roughly you can mark it. Otherwise you have to search through the whole entire ball. Okay. Now you can remove this ball. You can clean it with the help of this tissue paper before examining into the microscope. Okay. Now, if you see through the, with naked eye it won't be visible. You have to search through the microscope. बंद करो तो. Now, our lab assistant will show you the reading of the scar dia through the microscope. So you have to place the ball single by single, all three balls. Like now he put the first ball and he trying to check the microscope, trying to check the scar diameter through the microscope. He finded the scar diameter. So now you have to check. Inside that scale is there, 0 to 100. Okay. So you have to adjust this scale and note down the reading. So it is between, like, I guess 28 to 42. Can you confirm me? 28 to 42. Check the scar diameter. I guess from 28 to 42.
लाइट कर दो
28 to 42. Can you check? Nearby 28 to 42 is scar in.
Yes.
Huh?
Yes.
Okay. So this is the 28 to 42. That means 14. No. It's not visible in phone. So it's 28 to 42 means 14, and you have to multiply with the 10 because 10x resolution. So 140 micrometer is the scar diameter. So again you have to check with the second ball, third ball, and take the average. So at this corresponding 6 kg load, we perform 6 kg, we got like 140 micrometer is the scar diameter, and you have to repeat 2 times, like 8 kg and 10 kg again. Okay, that's it.
ओके
हाँ, अच्छा बना. He's my friend also, Jahangir Lama. He's the senior to us. He will help in all experiments related to research, related to M.Tech, B.Tech. He helped every student.
ओके सर थैंक यू सर So today's experiment is over. इसका diameter. So हरे कृष्णा आज के लिए इतना ही.
If you ask me in report what you need to write, so first write aim of the experiment, then apparatus requirement, then little bit of theory, then procedure, then observation table and calculation, and then at last result and discussion. And you have to plot the graph also, load versus scar dia, and frictional load versus normal load or normal load versus frictional load. You have to plot two graphs.
First come, first